All right, we are going to finish up postulates. And remember what a postulate is. So the word postulate is also known as an axiom. So you're going to see this word especially, axiom, shows up in funny places, but it'll often show up in SATs or state testing because for some reason they prefer the word axiom. Maybe it sounds more grown up. Axiomatic geometry, something like that. Sounds very intelligent. Okay, they're synonymous. They mean an accepted statement of fact. For example, you accept that I exist. All right, so the first one here, postulate number 1, and the numbers are never important. The numbers are not important. So it's the statement itself that's important. Through any 2 points, there's exactly, notice I misspelled, exactly one line. One line. So here we have 1 point, we have another point. There is only one line that I could draw between them, as opposed to this situation here where somebody said, oh look, I have a point and a point. Oh look, I can draw this line and I can draw this line. What's wrong with that? What's wrong with the red? It's not straight. It's not straight, therefore it's not a line by the definition of flat plane geometry. In other words, it could work. Okay, so exactly two points makes exactly one line. That's it. I can't put another one on top of that. These are all the same line over and over and over again. All right. Continuing on, postulate 1-2 again, unimportant about that. The most important says, if 2 distinct lines intersect and they intersect in exactly 1 point. So I have this line here, which is called line ED. I have this line here, which is called line NL. And the point where they intersect is M. M is the point of intersection. Notice over here, why is this a non-example? Why doesn't this work? How many lines do I have? 1 line there, 2 lines there, 3 lines here. So I'm not talking about 2 lines, I'm talking about 3 lines. So this is why it would not be. However, if I'm only talking about these 2 lines here, then D is the point of intersection. If I'm talking about these 2 lines here, then C is the point of intersection. Practically, if 2 distinct planes intersect, they intersect exactly in exactly 1 line. Good. This was on your quiz. And so the black line right there is the intersection. Practically speaking, in this room, you can see it anywhere in this room there where the 2 walls meet, you can see that there is a line. So this one is an attempt to be a counterexample. Look, I have a plane right here, and then I have another plane there, and look, they intersect at a point. So just to clarify, this goes on forever this way, this goes on forever in this direction, which means it will intersect right there, still forming a line. Just a bad diagram. We're forgetting that the plane goes on forever and ever and forever. All right, this one also is part of your quiz on some level, and it said this. Through any 3 non-collinear points, there is exactly 1 plane. 1 plane. Boom, boom, boom. Now that makes a plane. Now, why is this important? How have you used this? So this guy here, we have, do these 3 make a plane? Well, yeah, let's see. 1, 2, and 3, but where's the plane? The plane is this guy here. That's the plane. It's the plane that's upright, containing all those points. It just hasn't been drawn yet, that's all.